Welcome to this session. In this session, first I will go through what you have learned in the previous session, and then I will go through trip circuit mechanism of a circuit breaker, and then I will go through circuit breaker opening during fault and circuit breaker closing during fault, and a terminology related to the circuit breaker and a circuit breaker rating that I am going to discuss. Here, this is a topic that is discussed in the previous session, that is arc formation and methods of arc extension. Here let us see how an arc will be formed in the circuit breaker. When there is a fault on the system, the contact going to separate. Because of the separation of the contacts, the contact area decreases at the instant of opening of the contacts. Because of the opening of the contact, a contact area decreases, and there is a large fault current that is flowing through the circuit. This increases the current density. Because of increase in current density, temperature of the media increases. Because of that, heat is produced in the medium between the contact get ionized. Because of that, the arc is struck between the contacts. At the arcing period, current flowing between the contacts depends upon the arc resistance. Now, let us see what are the factors on which arc resistances depends upon. Arc resistance depends upon the three factors. One is a degree of ionization. Because of ionization only, there is a formation of arc in the medium, and length of the arc. How long it will be present in the system, and what will be the cross section of the arc for its persistence. Next, what are the methods of arc extension? There are two methods of arc extension. First one is high resistance method and a low resistance or a current zero method. In a high resistance method, there are four subdivisions. First one, lengthening of the arc. Second one, cooling of the arc. Third one, reducing the cross section of the arc. Fourth one, splitting of the arc. In order to do this, in doing this, we can reduce the resistance, and hence we can arc will be struck extension in the circuit breaker. Next, arc resistance or a current zero method, wherein which we can reduce the we can extinguish a arc by lengthening of the gap and a high pressure, cooling and a blast effect. Let us take a tripping mechanism. Consider a terminal connection. One of the terminal is connected with a current transformer secondary. Primary carries a large current on the occurrence of a fault. Because of the large current, there is a voltage appearing across the CT secondary. That voltage is sufficient to energize a trip coil of the circuit breaker. Trip coil of a circuit breaker, and there is a relay circuit. The relay circuit, after getting a sufficient energy, relay circuit trip coil closes. Because of the closure of the relay circuit, there is a energization of the relay coil circuit. Because of the energization, the moving contact move away from the fixed contact. This will give a opening of the moving contact from the fixed contact. Because of the opening, there will be a arc formation between the moving contact and the fixed contact. After there is a arc extension in the moving contact and the fixed contact separation. Likewise, there is a tripping mechanism occur in a circuit breaker. I will repeat this once again. In the tripping mechanism, there is a circuit breaker. This circuit breaker having a fixed contact and a moving contact. This fixed contact and moving contact are placed in a medium to extinguish a arc. That medium may be air, oil, SF6, vacuum, etc. Here, terminal of the circuit breaker is connected to the primary, and secondary of the current transformer is connected to the trip coil circuit, and this trip coil circuit contacts are connected to the relay coil circuit. This whenever there is a fault that is occur on the system, due to the fault a large current will flow through the circuit. Due to the large current, the secondary will get sufficient voltage. Because of that voltage, the trip coil get energized. Because of that, the relay contacts the closes, and this will give a tripping circuit. This will give a tripping signal to the circuit breaker. Therefore, circuit breaker moving contact will move away from the fixed contact. Therefore, because of that, there is a opening of the contact of the circuit breaker. Next, we will see tripping circuit mechanism and how a moving contact will move away from a fixed contact. At the instant of the fault, moving contact and the fixed contact are close together, and when there is a tripping mechanism, the contact after the trip coil energization, the contact area between the contact area is more. That is, fixed coil and moving coil contact area is more here, and as the figure goes down, there is a contact area is reduces by one figure to another figure. This is the contact area is more here, contact area is less. Here still less contact area between the moving coil and the fixed coil. And consider the another circuit. Here there is a contact area reduces. Because of the contact area reduces and there is a fault current, what happens? There is a ionization, there is a increase in the current density. Because of the increase in current density, the area between the medium between the contacts get ionized. Due to that, there is a arc will be formed in the contact, and this arc will be present up to certain distance. After that, the arc will be extinguished at current is equal to 0. Consider the diagram shown in the figure monitor. Here red line represents the occurrence of a fault. When there is a fault, there is a short circuit current represented by a blue line. Then this short circuit current is present up to this point. Afterwards, the short circuit current is 0, that is a clearance of the fault. Here, after a certain time, the trip coil going to energize. Means if the fault get maximum, then at that time, if the trip coil, circuit breaker trip coil get energized, it will get a relay time. When relay get a strip signal to the circuit breaker. Here the circuit breaker get a signal to the circuit breaker takes a signal by the relay. Because of that, the relay starts, the circuit breaker starts opening at that time. Here voltage across the circuit breaker. First, during the normal, during close, the open circuit breaker current is 0. After it is opening, the circuit breaker current is present, that is called as the arc voltage. Next, this is the point at which there is a production of arc in the system. Then when the arc current is 0, there is a restriking voltage. Then there is a opening time. Because there is a instant of the fault and the opening of the circuit breaker, it is called as the opening of the time. And there is a arc that is present between the contact of the circuit breaker. It is called as a arcing time. And in a transient will be occur when there is a opening of the circuit breaker. It is called as a restriking voltage or a transient voltage. After the contacts are separated, the fault will be clear. After the clearance of the fault, the system goes to its normal voltage. It is called as a recovery voltage. Then from the tripping signal to the opening of the contact is called as a breaking time. Next it will say circuit breaker opening during fault. What are the consequences that will be occur during the circuit breaker opening time? That is, first there will be a fault initialization. Next, energization of a trip circuit by a relay. Next, opening of a operating mechanism. Next, moving contact starts to move away from a fixed contact, and a final contact separation and a arc formation. Next, end of opening time and the beginning of a arc time. Circuit breaker closing during fault. Increase of arc length and resistance, and arc extension at I is equal to 0. And there is a voltage transients at circuit breaker contact, at which there is it is called as a restriking voltage. There will be a damping of a transient. Then because of the damping of that transient present at the circuit breaker contact, the system goes to its normal voltage. It is called as a recovery voltage. Next we will call as a circuit breaker open, that is called as a total breaking time. Next, circuit breaker closing during fault. First, in that instant, first there will be a line charging initialization. Next, energization of a closing circuit. Next, closing of the operating mechanism. Next, moving contact starts to move towards fixed contact, and contact between moving contact and fixed contact, there will be a contact between a moving and a fixed contact, and next finally the contact get recombination, that is a circuit breaker closes. Consider its waveform shown in the monitor. Here in the waveform there is a system voltage drawn by a dotted line. When there is a separation of a fixed contact and a moving contact, and that is not here, that is not there in the figure. Here red line indicates separation of a moving contact and a fixed contact. Here there is a fault current represented by a green line up to the initiation of the fault and the clearance of the fault. Initiation of the fault and the clearance of the fault, there is a voltage present between the contact of the circuit breaker. This is called as a arc voltage. When the fault current is 0, at that time there may be a restriking voltage. That restriking voltage appear as a voltage transients, that is called as a restriking voltage. That will be appear at the arc extension at the current is equal to 0. Next, there is a recovery voltage. After the current is equal to 0, the circuit breaker once again recloses. It is called as a recovery voltage. Now let us see some of the definition. It is a transient voltage that appear across the contact at or near current 0 during the arcing period. Next we will call the next definition is a recovery voltage. It is a normal frequency RMS voltage that appears across the contact of the circuit breaker after final arc extension. It is approximately equal to system voltage. Recovery means recovery from fault. After the recovery, the contact get closes. Next, arc voltage. It is a voltage that appear across the contacts of the circuit breaker during the arcing period. Next slide we will see rate of rise of recovery voltage. It is the rate of rise of recovery voltage. The unit of that is kilovolts per microsecond. Next we will see, before going to the rating of the circuit breaker, let us see what all the duties that are performed by a circuit breaker. It must be capable of opening a faulty circuit and breaking a faulty current. Faulty circuit, it has to be capable of opening a faulty circuit and breaking a faulty current. And next, it must be capable of being closed onto a fault, and it must be capable of carrying a fault current for a short time while another circuit breaker is clearing a fault. This is a duty performed by a circuit breaker. With this duty, let us rate a circuit breaker rating. Circuit breaker rating is did in terms of its breaking capacity, making capacity and a short time capacity. Let us see what do you mean by a breaking capacity. Breaking capacity is nothing but in terms of current we will say about the breaking capacity. It is the current that a circuit breaker is capable of breaking at a given recovery voltage and under specified condition. What are the conditions that we will take into account? that is a power factor and a rate of rise of recovery voltage. Next, the making capacity. This is also a current, but this current is in terms of a peak value, that is during first cycle of current after current wave after the closure of circuit breaker is known as a making capacity. Here all the capacities are, that is a making capacity, breaking capacity and a short time rating, all are those in terms of a current. One is RMS value of current and another one is a peak value of current. Here short time rating. It is a period for which circuit breaker is able to carry a fault current while remain closed. It is called as a short time rating. Means at the short, and before a circuit breaker going to open, it has to carry a fault current for a short time. Therefore, that time has to be calculated in the rating of a circuit breaker. Next we will see some of the multiple choice questions. Multiple choice questions are discussed on this chapter. That is, first one, the rating of the circuit breaker is usually determined on the basis of dash fault. First one, symmetrical. Second, line to line. Third, single line to ground. Fourth, double line to ground. Here, line to line fault, single line to ground fault, double line to ground fault, all of them will lead to unsymmetrical fault. Therefore, here we are not getting a balanced current or a balanced system along the on the system. Therefore, here with that value we can't calculate the circuit breaker rating. For calculating circuit breaker rating, we have to take a balanced system, voltages and currents. For that, we will take a symmetrical fault. Hence, for the rating of the fault circuit breaker, it is usually determined on the basis of a fault, symmetrical fault. Next, how is a restriking voltage is measured? That with the explanation you should be remember that whether it is a peak value and a RMS value. Here we are having an ambiguity between the RMS value and the phase value. Let us go through that restriking voltage. Restriking voltage. Let us go through that restriking voltage. It is a transient voltage. Transient voltage that appear across the contact of the contact at current is 0. It is called as a restriking voltage. That is, here in this case it is a peak value. We can't take a RMS value in this. The correct answer is a peak value. Next we will see the making and the breaking current of a three-phase AC circuit breaker is in the power system are respective in a what manner? Making and the breaking currents are going to measure a rating of a circuit breaker. Therefore, these are all instantaneous value. These are all not a maximum value. These are all a instantaneous value. These are all going to measure a rating of a circuit breaker. Therefore, correct answer is a instantaneous value of, that is a making current is also instantaneous value. Breaking current is also a instantaneous value. Fourth one, which of the following circuit breaker has a lowest operating voltage? Here Starting from the beginning, we are having a breakers. First one is a arc quenching media is air, then oil, then SF6, then a vacuum circuit breaker. Here air brake is the one which is having a lowest operating voltage. This is used in a outdoor circuit. Therefore, here the correct answer is a air brake circuit breaker. Next, circuit breakers usually operate under steady short circuit current, subtransient state of short circuit current, transient state of short circuit current. Here the correct answer is transient state of short circuit current is the correct answer. Next, what is restriking voltage? Transient voltage that appear across the circuit breaker contacts at the instant of arc extension. At the instant of arc extension is called as a restriking voltage. Another example is, another answer here in this case is the transient voltage that appear across the circuit breaker contact at the end of arc extension. At the end of arc extension is maybe that is a recovery voltage. Here the answer is a restriking voltage. Next, rate of rise of restriking voltage depends upon, what are the factor on which depends upon? Type of circuit breaker, capacitance of the system, inductance of the system, both capacitance and inductance of the system. Here the correct answer is both the capacitance and the inductance of the system. These are all the factors on which rate of rise of restriking voltages depends upon. Next, recovery voltage. Recovery voltage depends upon the final arc extension. Here, recovery voltage is the value of RMS voltage that appear across the poles of a circuit breaker before final arc extension. That is the correct answer. Remaining answer is a restriking voltage and a rise of voltage and all the above. These are not correct. The correct answer is a final arc extension. Next, which part of the circuit breaker is helpful in breaking a current? Which part? That is the contacts. Contacts are the parts which will going to break the circuit. A trip coil, contacts, medium and a handle. The correct answer is the contacts. Next, which type of tripping is generally preferred for the circuit breaker? Manual, automatically, depending upon voltage level. None of the above. The answer is automatically. It has to operate automatically. Yes. In this session, I have discussed about circuit breaker rating and some of the terminologies. Some of the terminologies like arc voltage, restriking voltage, recovery voltage, rate of restriking voltage, etc. we have discussed. Let us quickly go through what we have discussed about arcing voltage. It is the voltage that appear across the contact of the circuit breaker during the arcing period. Next, restriking voltage. It is the transient voltage that appear across the contact at the current zero. It is called as the arcing period. Next, recovery voltage. It is the normal frequency RMS voltage that appear across the contact of the circuit breaker after final arc extension. It is approximately equal to the system voltage. Here in this session we have discussed about this. With this, thank you for your patience listening. Thank you once again.